Monday, we're going to do one of these because there's some on the homework like this, and then we're going to go into 11.3. 11.3 is a law of cosines, and also all the area stuff will be in there. So we're going to take a look at this first one. We're looking at the NATO exercise in F-14 Tomcat. Left the Nimitz and went on a bearing of 34 degrees. So the first thing I'm going to do is draw a picture of what the heck is going on. Now remember, with air navigation, it's always off the north. So we're going 34 degrees. Right? And then it says he flew for 400 miles in that direction. So the length of that side is 400. The next thing it says is that he then flew a bearing off of 162. So I'm going to draw myself an additional XY plane up there. And the reason I'm doing this is because everything's off of the north. So from the north, he went 162, or she went 162 degrees. I have no idea how far they went on that one. And then it says the plane then flew back at a 308 degrees for the final leg. So once again, I'm drawing my XY plane so that I can get my bearing again. And it was 308 degrees. So from the north, 308 degrees. So somewhere like that. Okay? We're going to use the law of sines. Bless you. But we need to get some information in here. We're missing some of the angles because they're not given to me directly, so I have to find some of these angles. So what I'm going to do is I'm going to go and take this angle. I'm going to make it larger so I can see what's going on. So this looks like this. 162 degrees out. And then down here, I have this XY plane, and I'm coming out of there 34 degrees off of the north. So this is 34 degrees. Now the assumption is that this is running parallel to this. So if that's 34 degrees right here, that means this also has to be 34 degrees. So alternating interior angles of parallel lines. So if this one here is 34 degrees, alternating interior angles, this also has to be 34 degrees. Alternating interior angles. Now what I know is that this is 162 degrees right here. How much more do I need to rotate to get to the y-axis? 18. So what is this angle then equal to? This angle right here. This angle right here. What is this equal to? 52. So 52 degrees.
Where'd you get the 34 from?
Alternating interior angles. We assume that this XY plane here is running parallel to this XY plane. So we have alternating interior angles of parallel lines. This is one of those classes that everything that you learned and forgot is going to rear its ugly head in here. So everything you learned and forgot, you've learned all of this somewhere and you forgot it, is rearing its ugly head. Yes?
I understand the first graph, but I don't see how you got this second graph from that.
Okay. Let's try again. Okay. You got that? We're good? I'm going to take and look at specifically, I'm going to take a look at this corner. I want to look at that corner specifically. So I'm just going to blow it up so I can write it bigger. This is 162 degrees. Right? Do you agree to that?
Yes.
Do you not agree to that, or do you agree to that?
Why did you move where the x plane is? Before you were going at an angle, but now it feels like it's a totally different one.
So everything is measured off of the north. So all I'm doing is I'm taking this right here, and I'm just moving it over here so I can blow it up bigger. That's all I'm doing. So when they turned 162 degrees, with their first turning, it's 162 degrees off the north. So that the XY plane that I drew over here in red is the XY plane here in red. All I did is I'm just moving it so I can write it bigger. It's the exact same thing. How are we doing?
Just keep going.
Okay. Now, I'm going to do the same thing here. I'm going to take this, and I'm going to draw it small. So I'm just going to draw it small right there so that I can have a reference to it. Okay? What was, when I initially flew off of my Nimitz, what was the bearing on that? So from here to here is 34 degrees. So this and this match. So right here, this angle and this angle. I made it the small one. My initial starting point, I made it the small one. And I have the small one, now the big one, so I can find out what's going on there. We have this thing that says if we have parallel lines, and we assume these are parallel, that alternating interior angles are the same. So if this is 34 degrees, then so must this be. Because if we have a line that passes through two parallel lines, this angle and this angle must match. Okay? If we know that's 162 degrees, we need to go a distance of 18 degrees. So the final measurement for that particular angle was 52. So if I come back over here, I know that that angle is 52. So this angle we found to be 52 degrees. All right, 52 degrees. Now I'm going to do the same thing with this one. Do the exact same thing with this one. So I'm going to write it in blue. I know I'm coming out of there 308 degrees. So that's 308 degrees. Up here, and that represents this angle right there. I'm coming out of that 162 degrees. Do you all agree I'm coming out of the 162 degrees? This and this is parallel. So what I need to know is what that angle is. Yes? It's 52? Is it? Well, so what now? This is not drawn well. Right now is I don't know what that is, and it's not 52, it's 18. It's 18. This is 18 degrees. Why is this 18 degrees? Because this is 18 degrees. Alternating interior angles. Alternating interior angles. I am chasing, however, this right here. I'm chasing that angle.
Those are both 18, but one looks so much smaller than the other one?
Because it's not drawn well, not drawn to scale. I have no scale here.
So what you do, 360 minus 308 minus 18?
Yes. So to find this angle right here, I'm going to do 360 minus 308 minus 18 degrees.
34 degrees.
34 degrees. All right. So we know that this angle is 34 degrees, not drawn to scale still. So what is this leftover angle that I haven't found? What does that have to be? 180 minus 52 minus 34 degrees. And what is that? What is it? 94. All right. Now, I'm just going to rewrite the triangle itself without all that stuff on there. So here's my triangle, not drawn to scale still. 94 degrees, 52 degrees, 34 degrees, 400 goes here. Still not drawn to scale. They're asking for what is the distance it took on the final leg. So what they're asking for, we'll call this A. They're asking for A. They don't want the other side, they want that side. So I'm going to use the law of sines. Is this the ambiguous case? No, this is not the ambiguous case. So I just use the law of sines. So I have the sine of 52 degrees over A is equal to the sine of 34 degrees over 400. So then A will equal 400, somebody with a calculator, sine of 52 degrees divided by the sine of 34 degrees. Somebody with a calculator, tell me what that is to the nearest mile. Aram, did you get it? You think so? What'd you get? 564? Can somebody confirm that number? Okay. So there's some on the homework like this. Make sure you know how to do these.